Algebra 2 Honors 5.5 notes. We're going to be looking at performing function operations, addition, subtraction, multiplication, and division. So part of this is just getting used to the notation. And so here we have a chart with a notation. This means we're going to be adding the functions. This is subtracting. This right here is multiplication. It's f of x times g of x. And then we have the quotient where we're dividing. And so in example 1, we have two functions f and g, and they want us to find f plus g of x. And so f plus g of x means f of x plus g of x. It's the same thing. So we're just going to take f of x plus g of x. And so that is our f plus g of x. It is just simply, we would write f root x, 5 root x minus 8x. And then it says state the domain. Well, it can't be any larger than the original, and the domain of this is 0 to infinity. The range of domain of this would be all reals because it's just linear. And so this restricts our domain, so our domain is going to be 0 to positive infinity. And then they want you to evaluate f of 16. So f plus g of 16 means we are just going to replace x with 16. And so we get 5 times 4 is 20 minus 128, and you get a negative 108. And that's f plus g of 16. And all non-negative real numbers, that is the same as saying that the domain is 0 to infinity. It's just 0 is not positive or negative. And so it's just a phrase that I would like you to be familiar with, that instead of saying that the domain is 0 and all positive numbers, we can say that a little more concisely by saying the domain is all non-negative real numbers. And that means the same as this. All right, so then example 2, we have another couple of functions. They're both polynomials, and they want f minus g of x. And so f minus g of x is just your f of x minus g of x, but you need to make sure that you have that in parentheses and that you distribute that negative all the way across. And so you get 2x cubed plus 4x squared minus 8x plus 4 minus 3x cubed plus 5x squared minus 6x plus 9. And then when you collect like terms, oops, you are going to get a minus x cubed plus 9x squared minus 14x plus 13. And the domain on this, it's a polynomial. They're both polynomials. The domain is the set of all reals. So we have this, we have the domain, and then evaluate the difference when x is a minus 1. So we have the opposite of a negative 1 cubed plus 9 times a negative 1 squared minus 14 times a negative 1 plus 13. So we're going to get 1 plus 9 plus 14 plus 13, and that comes out to 37. Example 3. This right here, fg of x, means we are taking f of x and we are multiplying it times g of x. That's what that means. So you're going to be taking x cubed times the square root of x. So f times g of x is x cubed times the square root of x, but the square root of x is x to the 1/2. So they very likely will write this as 3 plus 1/2. 3 and 1/2 is 7/2, so x to the 7/2. Now, the domain on this, you are involving a square root, so we need all non-negatives, 0 to positive infinity. So there's f times g of x. The domain is all non-negatives. And then evaluate it when x is 4. So fg of 4 is that 4 to the 7/2, making use of structure. That's 4 to the 1/2 to the 7th. So you get 2 to the 7th, and that is 128. All right, example 4. We have a quotient. Now, this f divided by g of x just means we're taking f of x and dividing by g of x. But we can never let the denominator be equal 0. This is true, but g of x cannot be 0. And so we have to think, what value of x makes g of x 0? And that is going to mean that my domain can't let this be 0. After you simplify it, it might disappear. So you've got to think right away, what value of x makes g of x 0? And it is 0. So my domain is negative infinity to 0 union 0 to infinity. It's all reals except for 0. And so then with like bases, you subtract exponents, and you get 4x to the 1/3. 4x to the 1/3, or we'd probably write f divided by g of x is 4 times that cubed root of x, but you have to say x cannot be 0. Otherwise, we wouldn't know it, because when you simplify it, it loses that denominator, but yet if I put it into the unsimplified form, I could never use 0. So in the simplified form, I have to eliminate x equals 0. So there's the function. X cannot be 0. Domain, all reals except for 0 on that one. All right, and then they want you to evaluate this when x is 27. And so you get 4 times that cubed root of 27, which is 4 times 3, and that value is 12. All right, on the next one, they want you just to use, it says graphing, but scientific is good. They just want you to evaluate this. And they want you to evaluate when x is 3. So they want for f plus g of 3 is just going to be the square root of 3 plus the square root of 20 minus 3 squared. And in that, you can just, that would be a calculator activity because those aren't nice values. And you would end up with, to 2 decimal places, 5.05. And then they want you to evaluate f minus g of 3. So that would be root 3 minus 20 minus 3 squared, which comes out to be a negative 1.58 if you put that in your calculator. And then f times g of x means we are going to multiply that. So we have square root of 3 times square root of 20 minus 3 squared. And if you work that out, that comes out to 5.74. And lastly, we have f divided by g of x, which is going to be root 3 over square root of 20 minus 3 squared. And if you put that in your calculator to 2 decimals, it should come out to 0.52. So just make sure that you can evaluate those on a calculator. All right, example 6. From 2000 to 2010, the population in thousands of cities, M and N, can be modeled by these two functions, where T is the number of years since 2000. So it says find M minus N of T. And so that M minus N of T is going to be that 3.3t cubed plus 12.1t squared minus 0.65t plus 15.8, I didn't give myself enough room, minus 2.5t cubed plus 7.8t squared plus 0.41t plus that 11.9. And so the like terms, 3.3 minus 2.5 comes out to 0.8 t cubed, and then we get plus 4.3 t squared when we take 12.1 minus 7.8, and we end up with a minus 1.06 t, because you get a minus 0.65 minus 0.41, you end up adding those, but it's negative, and then 15.8 minus 11.9 is 3.9, so plus 3.9. So there is our function. And then it asks us to explain what that function represents. Well, m of t is the population in thousands, t years after 2000. And n of t is the same thing, but for city n. And so m of n of t, well, t is still going to be the number of years, but it basically, this expression tells you the difference in thousands of the population in these two cities t years since 2000. Or we can say the function represents how much larger city m's population is than that of city n's in thousands t years after 2000. And the last example here, being able to read using tables and evaluating. And so we have a table, and we have f and g being evaluated at x values of 0, 2, and 6. And so use the table to evaluate. Well, f minus g of 2 means f of 2 minus g of 2. We don't have anything to plug those into, but we have the table. And from the table, when x is 2, f is a negative 5. And when x is 2, g is a negative 3. So we get a minus 5 plus 3, and that value is a minus 2. In part B, this means product. So it means f of 6 times g of 6. And we get those values from the table. So when x is 6, f is a negative 4. And so I should see it like this so I know what you're getting from the table to see what values you're using to get the end answer. And g of 6 is 7. And negative 4 times 7 is a negative 28. And then lastly, this is the quotient. It means f of 0 divided by g of 0. And so when x is 0, f is 26. And for g, when x is 0, it is negative 2, and our answer is a negative 13. And that's it.